Hey guys, this video we're going to look at compound interest. It's a lot like what we did with simple interest in the last lesson, but this one is, it gets compounded, which means they add on the interest, and then that interest starts collecting more interest as well. So interest that is computed on the principal and any accumulated interest. So like I said, once you start getting interest, it accumulates more interest. So if you had $1 in interest, that extra dollar now starts collecting more interest. So there is a formula for it. A equals your amount, like the final amount. P is principal. R is the rate, the interest rate. Again, we're going to do that as a decimal, just like simple interest. Time is measured in years because the rate will also be an annual rate. And then N represents how many times it gets compounded in a year. So a couple of key words you need to know with that is annually means 1 time per year. Semi-annually is twice per year. Quarterly is 4 times. Monthly, obviously, that's 12 times. Weekly, 52. And then daily, we're going to use 360 instead of 365. Just because that's what it said yesterday. So when I go through these, if you look at these letters that we're going to be using here, it actually kind of spells out a word. I write it out as the word parent, but for right now we're just going to be crossing out the E. E is actually used on a different formula that looks very similar to these, so that's why I put it in there. But we'll just fill it out, and those are all of the variables that we need. P-A-R, like I said, no E, and then N-T. So it's going to start with the word parent. And then again, if you choose not to write the E because we're not using them right now, that's okay. But it is good practice because whenever it's compounded continuously, that's when we actually use the E. So that's just a slightly different formula that we use just based off of the word continuously. This one says annually, so it's not continuously. It will say continuously instead of annually. So you invest $4,000, that is your principal. The rate is 8.25, so we're going to write that as a decimal, 0.825. And it's compounded annually, which means N equals 1. And then this question says after 3 years. So we know everything except for A. That's what we're solving for. How much money will you have? So now we're going to plug it into the formula. Plug everything in where it's supposed to go. So, oops, extra 0 there. R is 0.0825 over N is 1, and time to the power of N times T, so 1 times 3 is 3. So you will use your calculator for these. Alright, so in our calculator, start with the parentheses. So, and then within that you would start with division, but that's not really any division. So we have 0.0825 plus 1 inside the parentheses. And then next you do exponents, parentheses, exponents, then multiply, just following your PEMDAS order of operations. So parentheses, then exponent to the 3, and then times, for multiplication, times 4,000. we end up with 5,073.92. So this is an investment, so this is good. You are earning money, and in 3 years you gained $1,000, which is pretty great. How much money will you have after 7 years? So it's the exact same thing, except T is 7 instead of 3. So fill everything in like we did before, and then our formula, 4,000 1 plus R over N, so that's going to be the same as before, to the N times T. 1 times 7 is 7. So it's a very similar start to what we had before. We're going to do 0.0825 plus 1. And then we're going to do it to the 7th power instead of the 3rd power. And then we'll multiply by 4,000 again. It'll actually run through all of that. And we end up with 6967. .15. So that should make a little bit of sense. First 3 years we gained $1,000. The next 4 years we gain almost $2,000 because that interest starts accumulating more and more interest. So it starts to grow faster and faster, which is really good for you if you're the one making the money. All right, so now we're going to look at what happens when you change how often it's compounded. We're going to change N. So in our equation, we write down parent. And again, like I said, you don't need the E in parent right now. So you invest $1,000 at 6 3/8. So let's go ahead and type in 3/8. That'd be 375. So 6.375. 0.06375. That's our R. 5 years compounded annually. Annually means one time. And we're doing 5 years. Going to solve for A. One plus R over N. To the N times T. 1 times 5 is 5. And then semi-annually, that's going to change. N is going to be 2. Everything else is going to stay the same. And I want to rewrite all that same stuff. So that's R over N. This time N is 2. And that is to the power of N times T. So 2 times 5 will be 10. Now quarterly, same thing, but this time N quarterly means N equals 4. The next one's going to be N equals 12. So we're just changing how often it is compounded. And we'll compare these values here. So divided by N, so now we're dividing by 4. And then this to the power of 4 times T. 4 times 5 is 20. Monthly, same. Over N, so over 12, to the power of 12 times 5 years. 12 times 5 is 60. Weekly, that's 52. weekly is 52, and then to the power of 52 to the, or times 5. So that's n times t. That's 260. And then this one for daily. We're going with 360 for daily. Yes, we know there's 365, but this is, according to our notes, that's what banks use, is 360. Maybe it's because they take off 5 holidays a year or something like that. I don't know. All right, and then our exponent is going to be 360 times 5. That's 1,800. So what you have two things going on with this formula. Our inside the parentheses is changing and our exponent is changing each time. So as we do that, this number is going to change. We start dividing, which will make this smaller. So like this one is 1.06375. And this next one is going to be half of that. So it's going to be 1.03 whatever. So the number here keeps getting smaller, but the exponent keeps getting bigger. So they almost cancel each other out. But exponents are more powerful than the dividing. So it will grow a little bit more. So we'll see that as we type these into our calculator. So for all of these, we do parentheses first. So that's 1.06375 to the power of 5. And then divided by, not divided by, times 1,000. So that's 1362.07. So our next one is a little bit different because we have to divide by 2. So that's 0.06375 divided by 2. And then we add the 1. And then we do to the power of 10. And then times the 1,000 in the front. 1368.58. So a little bit more. And all that changed is they compounded that money more frequently, which means that interest got added on and then started collecting more interest. So it does grow faster the more it's compounded. All right, same thing. We can go back to our 0.06375. This time we're going to divide by 4. And then we'll add 1. But then our exponent changes. It's going to be a 20 instead of a 10. And now it's 1371.95. All right, now we're going to divide it by 12. So again, we'll go back. We're going to change our exponent to 60. And we're going to divide by 12 instead of 4. So it goes all the way through, calculates 1374.25. All right, next one we're dividing by 52, and then the exponent's going to be 260. So that's easy, just put a 2 in there. But this time we are dividing by 52. Now we get 1375 and 14 cents. So you can see each time, the more frequently it's compounded, the more it goes up. It's not a whole lot. It was only like $1 more from going monthly to weekly, but still, that does add up. All right, and our last one we need to recalculate here. We divide by 360, and then our exponent is 1,800. We're dividing by 360. And then the power exponent was 1,800. And this time we get 1375. So not even $1 more. And 37 cents. Going from compounded weekly to daily. So this, just a little bit of a trick that you will see possibly if you pay attention to this stuff throughout life. When you have money in a savings account versus also having like a car loan or something like that, money in your savings account, number one, you're going to have less interest. The interest rate will be smaller. For example, the highest that you can find right now in a savings account would be less than 2%. Like mine currently, the highest I found was 1.75%. Whereas my loan for my car is a 4% interest. So number one, the banks are making money there because they're charging more interest than they are paying out on the savings accounts and things like that. And then the second thing that they also do, just to make sure that they make money, is savings account. My savings account is compounded monthly, but on my car loan for my truck, it is compounded daily. So those are two little ways that they make sure that they make money. It is a business, so they have to make money. So they charge you a little bit higher interest than they would give you on like a savings account and things like that. And they will also compound it more frequently when it's benefiting their bottom line, their finances. When it goes to them, they compound more regularly. So just two little things that maybe you'll realize and catch on, and just keep in mind as you go through life. All right, we are going to skip this problem because you can always go back and watch that last example again. I don't think we need to see another one. All right, so we'll talk a little bit about annual percent yield or effective annual percent yield. We did a little bit with this yesterday or in the last lesson also, but it's a simple interest rate that gives the same amount of interest on a compound rate over the same period of time. Again, we're using 360 days for a year. Everything's glitching on me. There we go. So we have our formula, the exact same, almost the exact same formula. It just doesn't have a P in it. It has a 1 instead. And interest is amount minus principal. So when it asks about interest, we just subtract the amount minus the principal. So when you look, basically it's like just as if you were starting out with $1 or something like that. Actually, what it is you're starting out with 100% of whatever it was. That's what the 1 is. It's 100%. So you start out with 100%, and then it's going to tell you what percent of that you'll have at the end. So the annual percent yield for $1 invested for 1 year. So that's really what we're just looking at from that formula with the 1s in there. 8% compounded daily. So we're going to take A equals 1 plus R over N, compounded daily, 360, to the NT, it's 1 year, so 360 times 1. So we're keeping the 1s that are in the formula, we're plugging in 360 for daily, and we're plugging in the rate, and we're plugging in 1 for T. That's where all those 1s come from. All right, so now we'll multiply that out. 0.08 divided by 360 plus 1. And then to the exponent before we multiply, but it's just a 1 we're multiplying by, so that doesn't even matter. And we get 1.08. Three, 2, 7, 7. So we'll go 3, 3. So what we really remember, then we subtract the principal, so we subtract the 1, and we get 0.0833. Move the decimal 2 spots to make it a percent, and it's actually like 8.33% instead of 8%. Because it's compounded daily, it behaves more like 8.33 instead of 8. It's more of like if you're going to compare it to like simple interest or something like that. 6% compounded quarterly. So again, we're going to do the same thing. We'll plug in that 1 in front. Really doesn't matter. Compounded quarterly means 4 times to the 4 times 1 for T. So 0.06 divided by 4 plus 1, and then to the power of 4. And then again, same thing, we would then subtract the 1. So it's really going to be like 6.14%. And that's because it's compounded quarterly instead of daily. All right, so present value, the amount of money or principal you must invest in an account to have a certain amount of money in the future. So you're just trying to figure out what do you need to invest so that you have a certain amount of money in the future. So like if you wanted to be a millionaire when you're age 67, you got to figure out how much you'd have to invest now, something like that. So just the formula we're going to use. If you look at it, it's really, really similar. It's actually just rearranging that older formula. So if you don't want to remember a new formula, you can use the same formula and just solve it differently. Once you plug in all the numbers, you just solve it. Because it is the exact same formula. If you multiplied this over here, you'd have the exact same formula if you multiplied the denominator over. All right, so to attend college in 6 years, Will would like to invest enough money now so that she will have $30,000 in 6 years. So we're trying to find how much now, so we're trying to find that P in that equation, and then that 30,000 is that final amount that we're going to have. And then we will divide by 1 plus r over n to the nt, just from that formula. 1 plus r over n to the nt. So r is 4.72. Compounded quarterly, that means 4 to the nt. So n is 4 and t is 6 years. So we're just going through, typing all that stuff in. Again, I would start with parentheses, and inside you specifically start with division. And then add the 1. And then to the exponent of 4 times 6 is 24. And now we're doing 30,000 divided by all of that answer that we got, just following order of operations. Divided by 1.325. Instead of typing it, I'm just going to do shift answer. All right, so to have 30,000 in 6 years, he needs to now invest 22,638. 22,638. And 57 cents. All right, that's it. Leave questions in the comments, like and subscribe, all that stuff. And I'll see you in the next one. Bye.